Hello, this is Lisa. We're going to talk about factoring trinomials in this video. First, we're going to start with a review of multiplying binomials. When we multiply, we use our distributive property, or with binomials, the FOIL method. Our first two terms, x times x, give us x squared. The outer two terms, x times negative 4, give us a minus 4x. The inner terms, 3 times x, or plus 3x, and 3 times negative 4 is negative 12. And we combine our middle terms to give us x squared minus x minus 12. What we're going to do today is the opposite of multiplying those. We're going to factor them, or in other words, do that kind of reverse FOIL. So there's a very specific method that we can use to accomplish this. If we want to factor trinomials with a leading coefficient of 1, in other words, it's just 1x squared plus bx plus c. We want to look at all possible ways to factor the constant term, c. Choose the factors that up to the middle coefficient, b, and write the trinomial in factored form, x plus or minus a factor times x plus or minus a factor, and check by multiplying. So let's work through these steps doing some examples. We're going to factor the following trinomials. The first one, x squared plus 6x plus 8. Step 1, we're going to look at all possible ways to factor 8. 8 factors as 1 times 8 and 2 times 4. Now, because all of the signs in my polynomial are plus signs, I don't have to worry about any negative combinations, because 8 could also be negative 1 times negative 8 or negative 2 times negative 4. In number 2, it says choose the factors that add up to the middle coefficient. In this example, our middle coefficient, b, is 6. 1 plus 8 is 9. 2 plus 4 is 6. That's the combination that I want, the one that adds up to my middle coefficient. And step 3 says write the polynomial in factored form as x plus or minus a factor times x plus or minus a factor. Our first term, x times x, gives us x squared. And when we know we multiply 2 times 4, we're going to get that last term, the 8. And if we think about where the middle coefficient comes from, it comes from the outer and the inner terms added together, which here would be 4x plus 2x is 6x. So we know we have the factors correct. If I multiply x plus 2 times x plus 4, this is a really good way to check that I have the right combination here. X times x is x squared. X times 4 is 4x, 2 times x, 2x, and 2 times 4 is 8. When I add the middle terms together, I get x squared plus 6x plus 8. So it does check. That was the original polynomial that I had started with. We're going to do a couple more examples. We have x squared minus 12x plus 35. We're going to start with our constant term, c equals 35. Now this time I do have a middle coefficient that is negative, so I want to think about my negative options here as well. Positive 35 could be 1 times 35 or negative 1 times negative 35. Could be 5 times 7 or negative 5 times negative 7. And I want to choose the combination that adds up to my middle coefficient, my b value of negative 12. So when I look at these combinations of numbers, negative 5 plus negative 7 is negative 12. And this tells me the combination of factors that I want to put in my parentheses. So this factors as x minus 5 times x minus 7. Again, you can multiply that out to check that you have the right combination of factors. In example 3, this one's a little bit different. We have two variables here, and I kind of think of it like this. When I know when I factor it, I'm going to have an x, and an x will give me x squared. To get y squared in that last term, I'm going to have a y here and a y here. I'm going to have one y in each of my last factors there. So I'm going to approach this primarily the same way that I did the last ones. My constant coefficient, or the ending term there, is negative 21. It's not really constant in this example because we have y squared. And how do I factor negative 21? It's 1 times negative 21, or negative 1 times positive 21. 2 is not a factor. 3 is a factor. 3 times negative 7, or negative 3 times 7. 4 doesn't work. 5 doesn't work. 6 doesn't work. I've already got 7 in my list, so I know I have all the possible combinations. The middle coefficient is 4. Which of these combinations adds up to a positive 4? Negative 3 plus 7 is 4. So that again tells me which combination of numbers I'm going to put in my parentheses. Minus 3 plus, not 4, but plus 7. And on this one, I am going to multiply it out because I want to check to make sure that I do have the right numbers in the right places. X times x is x squared. X times 7y is 7xy. Negative 3y times x is minus 3xy. And minus 3y times 7y, negative 3 times 7 is negative 21, and y times y is y squared. If I combine my middle terms, I get x squared plus 4xy minus 21y squared. What if we want to factor trinomials with a leading coefficient other than 1? We're going to follow pretty much the same steps, except that we're going to start by multiplying the leading coefficient and the constant term. In other words, the a and the c. We're going to multiply those two numbers together and then look at all the possible ways to factor the product a times c. Choose the factors that add up to the middle coefficient b. Now we're going to use these factors to split the middle term into two terms so we can factor by grouping, and we can always go back and check by multiplying. There are other ways of factoring trinomials, but this is the most consistent. It has a really nice method. If you learn the method, it works on every trinomial that you will ever see. So our first example. Step 1 says multiply the leading coefficient times the constant term. So 2 times 35 is 70, and we want to think about all possible ways to factor 70 such that the factors add up to our middle coefficient, or our b value. 70 is 1 times 70, or negative 1 times negative 70. Because that middle coefficient is negative, I know I have to think about all of those possible combinations. 2 times 35, or negative 2 times negative 35. 3 is not a factor. 4 is not a factor. 5. 5 times 14, or negative 5 times negative 14. 6 is not a factor. 7 is a factor. 7 times 10, or negative 7 times negative 10. 8 is not a factor. 9 is not a factor. 10 is already in my list, so I can stop at this point, and I need to find the combination whose sum adds up to negative 17. Negative 7 plus negative 10 gives me negative 17. So I know this is the combination that I want to use. I'm going to use that to split up the middle term. So when I look at my trinomial, I'm still going to have 2x squared, But this time I'm going to break this up into minus 10x minus 7x plus 35. Now I have 4 terms. I can use the method of grouping to factor. Group the first 2 together. We always want a plus in between our groups. Group the last 2 together. Factor each group. 2x squared is 2 times x minus 10 is 2 times 5 times x. They have a common factor of 2 and a common factor of x. And in parentheses, what's left? X minus 5 plus. When I look at my second group, this is negative 7 times x plus 7 times 5. I can take out the common factor of 7, and what I have left is negative x plus 5. If you look, these 2 factors are the same except for the signs are exactly the opposite. If I take out a negative 1 here, I'm going to have positive x and negative 5. Think about going back and multiplying that back out. So this is going to be 7 times negative 1. So now when I look at my factors, I have 2x times x minus 5 minus 7 times x minus 5. Now those 2 factors in my group are the same, x minus 5. I can factor out that common factor, and in parentheses, what's left is 2x minus 7. Both minuses are inside parentheses. I know that I'm done factoring. Now I'm going to go ahead and check this. X times 2x gives me 2x squared. X times minus 7 gives me minus 7x. Negative 5 times 2x is negative 10x. And negative 5 times negative 7 is positive 35. Combining the middle coefficients gives me 2x squared minus 17x plus 35. And if you look in your workbooks, that was the original polynomial that we started with. So we've checked it. We know we have the correct factorization. Got 2 more examples for you. Again, we're going to start by multiplying. 6 times 2 is 12, and we want the middle coefficient to add up to a positive 19. Again, all of my signs in my polynomial are positive, so I only have to worry about the positive options. 1 times 12, 2 times 6, 3 times 4. 4 is already in my list. Those are all the possible combinations. Notice here, none of those add up to 19. 1 plus 12 is 13, 2 plus 6 is 8, and 3 plus 4 is 7. So this polynomial is what we call prime. It cannot be factored. So this is one of the reasons that I use this particular method, is because you know when something cannot be factored. Example 3 says factor out a greatest common factor of negative 1 first. If I take out a negative 1, I'm going to be left with 2x squared minus 7x minus 15. And then I factor the trinomial, as we have been doing, multiply. 2 times negative 15 is negative 30. We need all the factors of negative 30 so we can see what adds up to a negative 7. 1 times negative 30, or negative 1 times 30. 2 times negative 15, or negative 2 times 15. 3 times negative 10, or negative 3 times positive 10. I can keep going, or sometimes you can look at it and just know which combination works. In this case, 3 plus negative 10 gives me that negative 7. I still have a negative 1 out in front, and now I'm going to have 2x squared, but instead of minus 7x, I'm going to have minus 10x plus 3x minus 15. So I've split up that negative 7x into a negative 10x plus 3x. Now, it doesn't really matter what order you put those middle terms in. I could very well have said plus 3x minus 10x. But if I can, because I know I'm going to be grouping here, I like to have a plus in the middle if that's possible. So, factor out your first group. We're going to have negative 1 times. And this, I can factor out a 2 and an x, leaving me with x minus 5. Plus, I can factor out a 3, which leaves me with x minus 5. Take out the common factor of x minus 5. And what do we have left? 2x plus 3. So here my polynomial is completely factored. And again, you can multiply that out to check it. 4m squared plus 12mn plus 9n squared. Again, as long as I have a square on the first term and a square in the last term and one of each of those in the middle, I know when I factor it, I'm going to have factors with m and factors with n. So I'm going to basically go along the same route. 4 times 9 is 36, and I need factors of 36 that add up to 12. Now this one I happen to be able to recognize right away. 6 times 6 is 36, and 6 plus 6 is 12. So I'll have 4m squared plus 6mn plus 6mn plus 9n squared. Group the first two together and the last two together. Factor out the greatest common factor for each group. First group, common factors are 2 and m, leaving me with 2m plus 3n. Plus, second group has a common factor of 3n, and what's left is 2m plus 3n. Common factor here, 2m plus 3n. And what's left? 2m plus 3n. If we notice those factors are the same, you can write it as 2m plus 3n quantity squared because we have two of the same factors. This is Lisa, and we are done with this section. Please proceed to the homework. Have a good day, everyone.